Okay, so I guess we've got who we're going to get in. So this session is on storage sanitization. I'm seeing that the words I say are being typed on my screen. I'm Eric Hibbard. If you were here earlier, I talked about storage security, and I am being joined by John Gelbman over here. John and I have been involved with the IEEE activity that we're going to talk about for quite some time, and we're pleased to say that the standard that we're going to talk about is finally published. And there's another component of it that is dangerously close. So I'm going to go in and talk about some of the higher level, sort of generic kind of stuff at maybe the manager level, and then I'm going to turn over to John to do a bit of a dive into some of the specific techniques, and then I'll do a wrap up. I think this translation is going to drive me nuts. Okay, so legal notice. I'm not a lawyer. I'm not your consultant. You pays your money, takes your chances. So here's an overview. All right, so to set the stage for talking about things like sanitization, we need to understand a little bit about data lifecycle management, and because when we start talking about storage management or storage lifecycle management, there are some intersection points, but there can be some differences. All right, so one of the things that in data lifecycle management we worry about is basically data destruction, data disposal. How do you make things go away? And that making it go away is critical to avoid data breaches. And depending on what lawyers you talk to, some will say get rid of data the instant you don't need it any longer. Others will say, well, you should probably hang on to it for whatever reason for a while. But the longer you keep data around, the more likely, especially if it's sensitive data, you're likely to run into problems with data breaches if your security is not up to snuff. You're probably familiar with discussions around circular economy for storage. And again, you see there's this interesting little life cycle. And of course, we want to draw your attention to, on sort of the upper right-hand corner, sanitize and verify. Did you make data go away at some point in this life cycle? And we could probably do a full-blown talk on just that little life cycle there. But so talking about destroying or eradicating data, you notice I didn't say the word delete or some of the other terms that exist. When you're looking at this from a data lifecycle management perspective, you have to, if you're making data go away, you have to get rid of all copies everywhere it exists. That means you may have to go find it on backups and everywhere else. That's not necessarily the problem we're trying to solve with the new IEEE standard. Keeping in mind that storage technologies are very good at trying to prevent loss of data, so when you actually intentionally try to get rid of it, some of those mechanisms can create challenges. We're very efficient at that. We're hyper paranoid about it, but if you actually have to make it go away, you have to make sure that you've accounted for all those things. A lot of times you're doing this for compliance reasons, and so the record keeping is a critical element of it. And if you fail to keep the records, I know of instances where people have deployed expensive technologies, run them religiously, forgot to turn on the logging, had a loss of a drive, and had to go through the full data breach protocol because they could not prove that the encryption was on, for example, so that when the drive disappeared, it was sanitized. So this paperwork, so to speak, these records are critical in the data lifecycle management piece, and it also applies in the storage piece, all right? There are very good forensics tools out there. And when we're looking at doing data sanitization, and in particular storage sanitization, in many ways, you don't want the drive data protection mechanisms to basically give the forensics folks back the data that they're after. If we've done our job right, the forensics tools, at least when you look at the drive, should not be able to recover the information. Now, forensics tools actually go a little broader than just systems. They, the drives, they'll actually look at the systems and anywhere else and see if they can find the data that they're really actually after. When looking at making data go away, you really want to understand the underlying sensitivity of the data that you're dealing with and the potential harm that you're dealing with. And if you're worrying about the cafeteria menu, unless, maybe you're in, some sort of special chef school, odds are it's not going to be sensitive, and the amount of effort that you'll go to actually make data go away is not going to be a significant issue. But we are seeing a lot of organizations, they don't do things like data classifications. They don't understand underlying what they have, and then they treat it all as if it were like secret or top secret kind of information. There are lots of confusing language out there right now. Data deletion, secure data deletion, the list is long and distinguished. We're trying to focus on the use of data sanitization and storage sanitization as a more precise terminology. And in fact, we are defining data sanitization. We are defining storage sanitization, whereas these others are not. And unfortunately, some of this is showing up in regulations. And that's an issue that we're trying to contend with. So what is the definition of sanitization? Well, it's a process or method to render access to target data on storage infeasible for a given level of effort. And there's, as you can see here, a few provisos. Access means you can't get to it. That means it may actually have just, it's gone, but you may be deprived of a mechanism to get to it. It might be there if there was a way you could get to it. Target data is what you're actually focused on. In general, we're worried about user data. But what we've found is that in some cases, there may be some metadata that is also important. And so that may be part of the target data. And infeasible for a given level of effort, this really comes into play when you're looking at things like cryptographic erase. So you've encrypted it, you're essentially going to destroy keys. If the encryption algorithm you used is DES, well, you probably didn't do a really good job of protecting it, and it's most likely going to be recoverable. So again, you want to make sure that the effort that's going to be required to get the data back is commensurate with the sensitivity or lack of sensitivity of the data. All right, so some more sort of terminology. Data sanitization is focused on all instances in all forms of storage. It's aligned with DLM and basically the destroy option there. Storage sanitization is focused on elements of the information communications technology infrastructure, and there are two flavors. Logical sanitization, which you'll see, for example, in cloud. That's a good example but it could be in virtualized environments as well. And then media sanitization is on specific media and or devices. And the IEEE standard that we will be talking about here shortly is currently focused on the media sanitization piece. Okay, so what are some common aspects of storage sanitization? Well, first of all, it's what kind of storage do you have? So you've got to identify it. Is it logical, virtual, or is it media aligned? And that's going to be critical because that will determine what kind of techniques you can potentially use or methods you can use. Then the method that's going to be appropriate. Lots of organizations default to destroy, which in the cloud world doesn't actually work. You can't really go destroy somebody else's cloud. So you can see why the understanding of the type is going to be important. And then once you know those aspects of it, then what's the specific technique that you're going to use? So in the case of virtual on the cloud, it might simply be an overwrite operation, or it might be cryptographic erase. You encrypted it, you basically blow away the keys. Oversimplified, but basically that. Of course, you want to verify the results to make sure that what you thought you did actually occurred. And then last but not least is making sure you've got a record of you did it, I verified it, and I recorded that set of transactions, okay? So what's going on in the sanitization standards? First off, I've mentioned IEEE 2883. This is the actual new standard for sanitizing storage. It was actually published, a couple weeks ago, 3 weeks ago. The ink is barely dry. We've been working on it for about 14 months. We believe that this is going to be the go-to standard for how you make data go away on specific devices and media. And we think over time that this standard will be refreshed, probably on a 2 to 3 year cycle, as new forms of media occur, new kinds of attacks materialize and whatnot. Upstream of that is an ISO standard 27040, which is focused on storage security. It was originally published in January of 2015. It was a guidance standard. The new version is currently at draft international standards stage. So if you're a standards geek like me, that means it's almost done. In fact, on October 3rd, the last technical changes will be locked in terms of what's possible. So this document is getting very close to its revision, and it does now include requirements, and there are requirements around sanitization. Upstream of that is the ISO 27002 document, and it is now pointing at 27040. So you see that there's a series of connections here. This is all important because auditors follow this trail, and that means auditors are going to show up looking at 2883 as, did you do this to make the data go away? And it's going to become, I think, an important aspect of this problem set. We are working with NIST to try and get them to update the ancient 888 document that is out there. Most likely, if we are successful, they will end up pointing in the direction of 2883 so that they don't actually have to spend or duplicate the amount of time that IEEE has already gone through. All right. So common aspects of the storage sanitization. Coming back, where do these things fall from a standards perspective? So the identification is most likely 27040 is going to be where you want to look to help understand that. Selecting the sanitization method, you see the question marks. Risk-based, neither 27040 or 2883 really deal with that. There is a proposal for a 2883.1 to maybe take a look at this, but right now it's what you're comfortable with from a risk perspective. Execution of a particular technique, definitely the space for 2883. The issue of verifying results, both 27040 and 2883 make suggestions. Again, this is an area where some future work is likely to be undertaken. And then the particulars in terms of what kind of evidence to produce and what should it contain is covered in 27040. Right? So this is, as you saw earlier, this is the full range. You see these two documents, for the most part, cover what you need to worry about. In the case of the selection of the method, once you pick a method, then 2883 will help you work through, is it really the right method you should use? Okay, so what are the methods? Clear, purge, destruct. Clear is a logical technique. Think of that as like overwrites. Purge could be physical or logical. Physical could be a degausser, although increasingly degaussing is less effective. Logic could be, for example, cryptographic erase. And destruct is, as the name implies, you are unleashing Sparky on the drive or the media and a range of basically techniques. Now, both purge and destruct are intended to deal with state-of-the-art laboratory techniques. So the intention here is that you could have somebody use an electron microscope or a variety of other techniques to try and recover the data. The data is of enough value to warrant that kind of activity. The difference is purge leaves the drive in a usable, potentially usable state. You might actually have to do a reformat or something, but it's usable. Destruct, it's gone. It's toast. Okay, so state-of-the-art techniques, so I mentioned it, disassembling and basically putting drives on a spindle and going after it, looking at it through electron microscopy. You get the point. These are advanced techniques. These are techniques that would potentially be used by nation states or very, very well-funded organized crime or, those kind of players. But the work that's been done is keeping this kind of attack adversary, in mind. Okay, so considerations when selecting a method, the sensitivity of the storage data. What are your policies? So if your policy says we always destruct, we always destroy, then obviously you're going to have to follow your policies. We're hoping that organizations will actually do less destruct and maybe more purge in the future. And that's where the environmental impacts come into play. In terms of recommendations, this is really to help guard against data breaches due to mishandling of media. And if you look at the 27000 series, they are definitely pointing to 27040 and it in turn to 2883 to help deal with the drive came out. And it could be something as innocent as a customer engineer coming in and replacing a drive that's flaking out and walks off your site. And that actually constitutes a data breach in some environments, certain jurisdictions. So you want the ability to say, not a problem. When it came out, because of the inherent cryptographic erase functionality, like for example, in the Keeper IO discussion, comes out, key cache is basically flushed. Then you've kind of dealt with this problem. And we are definitely encouraging the use of purge as in the form of cryptographic erase for the future wherever possible, just to keep the amount of landfill down where we can. This is from the 2883. By the way, there's a quiz on this in a little bit. This is the process that one potentially goes through, and you see clear, purge, and destruct on the left-hand side. So this is your entry point. You've made a decision, I'm going to do one of these. So let's say you start at clear, and you execute the method, and when you do the verification piece, it appears that it wasn't completely effective. Somewhere along the line, maybe it's like a hard disk drive with lots of bad sectors, and you get lots of errors back indicating, I wasn't able to get rid of everything because, well, the bad sectors may prevent me. And the way this is designed is, well, that may not be enough sanitization for this situation, so let's try a purge. And again, you go through that. Well, it may be that maybe the drive isn't, you can't degauss it and encryption wasn't used. So in that case, a purge wouldn't be a a usable mechanism, which then drops you down into a destruct mechanism. So this is really intended to sort of guide you through, once you figure out your starting point, this is intended to kind of help you figure out ultimately where you need to go. You may actually have to do multiple clears, maybe multiple purges before you get to the point where you've effectively gotten rid of the data. Okay, so with that, we're going to move to talk about the actual techniques. And for that,
and I should have sound. All right. So, John Geldman, Kioxia, and fairly involved in SNIA and NVMe and multiple other committees like IEEE, SysWeek. So let's talk about some of the factors affecting the ability to sanitize. And I will admit, as I read this, this is uncomfortably close to my garage. The storage media is not identifiable. Tape cartridges are often labeled with technology and generation. Some may not be labeled. Maybe in an enclosure that is sealed, printer, laptop, what have you, and you can't get to it, cell phone. You may be actually embedded inside a chip, which we now make chip-sized things, which are quite functional. And it could be that the organization lacks the expertise anymore to sanitize that type of storage media in a way that would leave it usable, or to verify that the sanitize was successful. As an example, I do have some 20 meg tape cartridges that I used to use for backups of my personal computer that I no longer can deal with and haven't figured out what to do with yet. So the equipment could not be working. You might have a drive to deal with those antique cartridges, which just doesn't work anymore. Or that equipment may be gone, which is my case. So we talked about those three basic techniques: clear, purge, destruct. We're really focusing our future activities and everything that we're trying to get the most use out of for purge. One of the early examples of clear was rm_star, which actually just removed the file system table and left all the data in place. We don't even call that a clear anymore, because it left all the data in a relatively easy way for anybody who has the incredibly sophisticated capability of dumping LBAs to still get to it. But if you actually overwrote it once, did a format, you probably got rid of a lot of the data, maybe not all of it, but a lot of it, and we'll call that a clear. Purge, on the other hand, has higher goals, and that's why we like that language. So sanitize, overwrite, the sanitize commands that we've built into SAS, SATA, and NVMe, all of those fit into this world. So the overwrite version of that, the block erase version of that, the cryptographic erase versions of that. DeGauss, with some special precautions, that works. DeGauss in these days of Hammer, I'm not quite sure how that's going to work. When it comes to destruct, the world is changing on us also. Melt, incinerate, things which cause phase change memory, as in phase change to ash, phase change to liquid, those are good. If you're just shredding into quarter-inch pieces of a NAND die or a disk, there's still incredible amounts of data in there for a nation state to go search through. So let's talk about overwrite. We have multiple meanings when we talk about overwrite. There's lots of DoD safe overwrite techniques, which overwrite through the address bus. Not so good. This is not what we're talking about. You need to use the Sanitize overwrite that can get into all the nooks and crannies in the device, SSDs, over-provisioning, hard disks, spare tracks. Those apply to them all. There are some security erase units, the unmap commands, the format NVM, which go a long way, but don't quite meet our definition of purge that we've established in 2883, but they are an effective clear. Sanitize overwrite is going to go through to all logical and physical locations within the scope of Sanitize, which is typically a device. We've defined this, 2883 is a media-oriented specification. And of course, there are media that overwrite in any form is just not capable for. A black marker over your paper is not sufficient. So there is a myth that overwrite for flash is going to cause a huge write amplification myth. And it is true that in the overwrite command in Sanitize, we give the option, if I remember correctly, for 16 passes. But if you hold that to one pass, it is actually fairly effective at getting through everything at the cost of that one extra erase for SSD devices. One of the things to be careful of, though, is that if you do your overwrite in such a way that you leave the device completely full, that's actually not a good place for SSDs to be. SSDs like to be deallocated from data that doesn't matter so that you don't end up in write amplification. Most SSD makers take that into account. So, as I said, this does add up for SSDs for at least one erase cycle, depending on how many passes you make. And so, however, when you get into the value of the data, sometimes the value of being able to verify that every accessible byte is gone in a really clear and certain way is worth the cost of that erase cycle. And right now, that's absolutely an operational decision. Okay, block erase. Block erase is great for NAND-based SSDs as it allows large regions of storage to be erased in a single operation, and we can do that serially and go through at a much higher rate than it would take for overwrite. We don't have anything for magnetic media today that's similar, but let's not give, maybe we should challenge our HDD friends that, why can't you do that? Seems like you ought to be able to do that in a hammer world, but we'll leave that up to those engineers. Right now, you can't do it. And after a block erasure, one of the things that happens that you may not be expecting is that SSD makers tend to do a lot of integrity checks. And we are very, very careful not to allow bad data out of the device. It's our #1 rules that our customers demand. And so we've blown away all that integrity data along with the real data. And so now we don't know if that's good erase data or bad erase data. So after a pure block erase, the device is typically not readable. And the usual thing that SSD makers do today is they just deallocate because they don't want you reading it because you just can't actually read the media yet. So in that case, though, if it was to be made available, it's probably true that that data would be either all ones or zeros, depending on some implementation details. So this will reduce the negative impact of that 1 to 16 erase cycles. It'll bring it down to you used one in the process of getting rid of the data, and it does actually physically get rid of the data in a satisfactory way, according to most NAND makers and Kioxia as an example. There are some things which you'll see if you're a student of the standards currently being developed, where if you don't complete writing a zone within some time, we've talked about that there are issues with that memory degrading over time. You need to clean things and close them out. For block erase, NAND makers and SSD makers do have you covered on that. There are some implementation-specific things that we do that leave the device in a writable state, which is not fully erased after the erase operation. We do some minor tweaks and the device is stable and not a problem. Nothing's going to go bad after a block erase. Cryptographic erase. So this is a method of sanitization in which the encryption key for the encrypted target data is sanitized, making recovery of the decrypted data infeasible using state-of-the-art laboratory techniques. So this is a media-based that we're talking about for 2883, but this is also true for other things. 2883 covers the case where the encryption key is within the device, well known to the device, and not known to anybody else. Is if you're saying with one hand that you're going to throw away the key, you still have it in your other hand. You haven't really sanitized anything. And that's one issue to be resolved in the case of logical sanitization that we deal with currently in our media sanitization. So ISO IEC 2740 has some preconditions, and actually some of these are also in some of the specifications of the SAS, SATA, and NVMe. All the data, all the user data on the device needs to be encrypted, or the device itself cannot actually be encrypted. And we have rules about that, and that's part of those specs in 2740. The strength of the cryptographic algorithm, that's 2740, has to be at least 128 bits. The level of the entropy of the encryption key also has to be 128 bits. We hope it's not, if you use 11111111 as your key, you probably have a problem. We want to make sure that all copies of the encryption key are actually sanitized, and that's how you can make the logical sanitization work. 2883 focused on the media sanitization with some of these other hints in 27040. When you're to figure out how well you've managed to hide things, depends on how well you've managed to eradicate the data, depends on a couple of factors. The strength of the algorithm you used, the level of entropy that was used in the encryption. It's much easier to blow away keys and much faster than it is to do anything else. The initial idea of sanitization was actually a request from DoD consultants who were concerned about compact flash systems going down behind enemy lines. They wanted it to be fast. And cryptographic erase can be executed in seconds by the time you run through all the various things, and sometimes much less than that. It can also be used as a supplement or in addition to other sanitized approaches. And also, you can do an additional and unneeded sanitization using a clear method to reduce the attack surface by preventing access to the ciphertext. Okay. So let's talk Destruct. So we talked about melting, changing to a liquid state. Talked a little bit about incineration, changing things into ash. These are not particularly green operations anymore. It's not particularly what we like to see, but it's sometimes what we have to do. There's a lot of environmental risks. If you look at some of the old practices of sending equipment to be recycled, where it is incinerated by the use of burning plastics with metals chiseled off with rocks in underprivileged countries, that is not very green. So it's too much energy to do it right and too much pollution to do it wrong. We are unfortunately in the place where some of the old, previously appropriate things to do, shred and pulverize, give you a certain amount of protection. Device is certainly not reusable, but if you're at a nation state sort of under that kind of attack, there's still a huge amount of data and an eighth of an inch cube of almost anything in a modern storage media. Verification and documentation. Two parts to verification. One is you want to verify that you actually did the operation, that someone actually verifies, yes, I ran the command. You want to document that for your potential liability records. And also, you want to check to see, did it actually work? There have been, unfortunately, too many documented results of people getting their firmware wrong and having errors. It didn't actually do what it said it was going to do, and the command was actually run. And also, it's just a good thing to do. So both of those are there. In 2883, we do recommend a full verification on a purge. What your organization does is up to you, but that's what is recommended. And for Destruct, you no longer have anything which is particularly usable. You need to ensure what state it's in or if the size of the resulting particles meets your organization's requirements. So again, we'd like to emphasize failure to document these two things could result in data breach protocols. I believe the talk from the Bar Association in the Security Summit, I think, could be summed up as follow our rules or we'll see you in court. So 2740 defines the specific information that should be recorded, best practices, and those are now interesting from a legal point of view. When did it happen? Who performed the operation? Where was the operation performed? What equipment performed the sanitization? Which method was actually used? What verification method was used? Who signed off on the verification? Final disposition of the media. And so an audit trail is appropriate and some kind of certificate. And I notice we're running out of time, which is great because we're about to move to our summary.
Okay, so some conclusions for our summary here. So storage sanitization, it's definitely a security control that if you're trying to avoid data breaches is something that you need to basically include. We've said it multiple times, documentation, documentation, documentation. We believe the 2883 is going to be the go-to document. Now that it's published, we are actually doing work not only in the IEEE, which is the International Standards Organization, we're also looking to work with ISO, obviously the relationship with 27040, is an important element, but we're also looking at Senelec and other entities including NIST, to recognize this standard. And of course, as said multiple times, we would like to see the use of purge whenever possible, as opposed to destruct, just to be good to the environment. But the work is not done, and here's some examples of some other issues that are going to need to be addressed at some point. And so you can anticipate that future activities will result in either additional standards or revisions to 2883. As I said earlier, we think the refresh cycle on this standard is going to be probably in the order of 2 to 3 years, as opposed to 7 or 8 years, which is what we've seen with the NIST document and the original 27040. And if you're interested in engaging, definitely join the IEEE Security and Storage Work Group. Its activities for doing that. Within SNIA, the Security Technical Work Group has definitely been involved, but the actual work is done in the IEEE Security and Storage Working Group, which is part of the Cybersecurity and Privacy Standards Committee. And if you like ISO kind of work, there is a US committee that interfaces with the appropriate ISO SE27 activity. If you have questions about that committee, I chair the US mirror committee to SE27 and can talk to you about how to get connected. Some standard resources. Hopefully you know about some of these already, but if not, they can be useful in the data security and data sanitization in particular. And we'd like to thank you for your time, and please rate the session if you found this to be useful. Yes? I don't have an answer for you on that one.
So Sanitize, so an overwrite operation, normal overwrite, or as an example, a format, which is not a quick format, will get rid of an awful lot of the data, but obviously will not touch any over-provisioned data in an SSD. But it will basically allow that anybody who's trying to get stuff out of the interface is likely not to be able to get it. So it's a simple, quick and dirty thing. It's not a purge. The sanitize overwrite is different.
Sorry, what I saw was it is overwrite is and effective, meaning clear.
This is true. Well, okay. For the purposes of clear, which is not very strict, it can be effective from the feasibility of an attack through the normal LBA interface. It will not protect you beyond that. When we talk about various legal requirements, whether that's sufficient is a whole nother question.
So, yeah, the reference is if the drive wandered off, for example, in the case of maintenance personnel came in, pulled the drive, and walked out, and you realized after the fact that they had swapped in another drive. In that case, even with Keeper IO, if you had the appropriate trail that it was basically being used to encrypt the data, then you wouldn't have a data breach protocol. In this case, I agree that the keys would still be known somewhere else. It's that the guy who walked out the door with the drive doesn't have the keys, and the keys aren't on the drive. So it's effectively been sanitized. Now, if you put it back in the system, it would be usable the minute you basically loaded the key cache. But this is, in many ways, we do encryption at the drive level, as we're trying to guard against these accidental, wanders, basically loss of control. And that's how a lot of the data breaches are defined, as loss of control. So literally when I hand him the drive, that may already put me in difficulty. Paul?
Where would I go to get my hands on the standard, and how much do I pay?
It has to be purchased. You could purchase from the IEEE store, and to be honest with you, I don't actually know the price off the top of my head. Okay, $83. Every worth a penny. Those of us who worked on it got a free copy. Yes, sir.
Never worked in defense contracting, but some of my high school and college buddies did. And the story they told was when they made a copy on the Xerox machine, they were forced to print 3 blank copies right afterwards because there was potentially residual data sitting on the Xerox machine still. That may be true on a flash erase command as well. So if you're really going to define state-of-the-art laboratory, it might be something to think about. And maybe the question is, I like the idea of state-of-the-art laboratory. Who decides what is state-of-the-art?
That was so. Who defines state-of-the-art laboratory?
I believe that falls under the category of the eye of the beholder.
Yeah. Yes.
It's not like this is going to say this is the state-of-the-art.
It's whatever we could get somebody to admit to in public.
I guess somebody said 128 AES was state-of-the-art, right?
Well, depending on, our friends in the NSA have recently kind of upped that to maybe 256 in preparation for quantum.
So I guess those guys are starting.
Yeah.
It's good to kind of report.
Right.
And lastly, you talked about the documentation. Do you see the drive itself creating some immutable certificate saying it's been sanitized? Or is this a paperwork with a human signature sort of certificate?
Yes. So both, well, in particular, 27040 sort of recognized that you'd want a way to capture sort of as routine operations, some of these kinds of transactions, and so that's why audit logging is actually identified as one potential source. Some organizations actually mandate the use of paper certificates, and I've seen that. So 27040 sort of identifies that under the heading of proof of standardization, that there's a couple ways you can go. But we've seen a lot of financial institutions, they want a stack of papers somewhere that you may or may not be able to search, if they're audited, but they've at least got the trail. Right.
And so this is pretty huge from a green economy standpoint to try to figure this out. It's just a matter of, in my opinion, every hyperscale I've ever talked to said you can try this drive on like 10 fingers.
Well, I mean, and I guess maybe as a positive turn, we've had conversations within OCP where the hyperscalers are operating, and they are basically giving requirements. And when they were working on their some of their SSD specs, we were strongly encouraging them to point in the direction of the IEEE 2883. We weren't really getting a lot of resistance. I think it was more of a, they weren't aware that there was a standard that went into the detail level that it does. So we are seeing some potential uptick on that.
And there is some work in the industry in the various interfaces to actually improve what we document within the device. That stuff isn't there and available for people to use now. And we absolutely encourage all the people who, you know, in those groups, we have both producers of media and consumers of media. And we hope we're getting everybody's input on what's sufficient auditing information on what we can do. And like any standard, there's going to be some negotiation back and forth between the producers and consumers about between what's practical and what's acceptable. And hopefully we'll end up in a good place. Oh, there's no, so we are out of time and we just got carded. But to restate the question, for dead drives, your option is no longer purge, you are now in destruct. We didn't give that as an option, but it works.
Thank you.
Thank you.